All right. So we had come up with that sentence, and that led us to writing sort of a helper, count persons. And again, the difference between count persons and count ancestors is that count persons actually includes this person, and count ancestors doesn't, because I am one of the persons in my tree, but I am not one of my own ancestors. So that's the distinction between the two. And so for the person case, the count ancestors were simply encode what we just said. And then the count persons, which I just completed, we discussed this yesterday, it's simply one, which is me, plus the number of persons in the mom's side, plus the number of persons on the dad's side. Okay? Did you get a chance to think about this accumulatively? Count the number of persons using an accumulator. Did anybody try it out? Well, you need all the practice with accumulators you can get. So please try the things out that I suggest that you do. But let's go through it real quick. Question number 1, what is it that we are accumulating? So let's accumulate how many persons we have seen thus far. Okay? And so I will write one over here. Count persons help. Count so far. Okay? Now, to understand how to update the accumulator, which is basically step 2, it helps to kind of look at your example and visualize or try to imagine how this method is going to accumulate the counts as we go along. Okay? And so let's say we start here, and at n, the accumulator is 0. So first, we are going to go to the mom's side, so right here. And so when we reach Beth, the number of persons we have seen thus far is n. And so what Beth should get is 1. Okay? So it does its own thing, but then what happens when Anne says this dot dad dot count persons? How many persons, what is the accumulator that gets passed to Bob? And that's really the big question. It's the second time you call it. So if our accumulator is counting the number of persons seen thus far, by the time I reach Bob, how many persons have I seen thus far? Anne, Beth, Chuck, Caitlin, Dustin, and Daisy. So to stay true to the definition of my accumulator, I should be passing the number 6 to it. Okay? So this is what should get passed here, if the accumulator is supposed to represent the number of people I have seen thus far. Okay? Now, what happens? So let's continue from Beth. So Beth will pass an accumulator of 2 to Caitlin. Caitlin is now going to call this dot mom dot count persons help and pass a number 2 here. Okay? And so 2 is going to get returned right here. So 2 is the number of people that I have seen thus far. Oh, sorry, 3. I made a mistake. 3 is what gets passed here, because Caitlin counts herself, and so 3 is what gets passed back. So far, we have seen 3 people. So that is the accumulator that Caitlin needs to pass to her dad. And then the dad is unknown, so just return what was passed back. Caitlin is done, so just return 3 what is passed back. Now Beth. Beth is now going to call the method on Chuck. And so how many people have we seen thus far? The number of people we have seen thus far are Anne, Beth, and Caitlin. So 3. Okay. So notice what is the number that gets sort of propagated down to the dad. This number 3 is coming from right here. Right here. Yes. So that's what I'm saying. So when it goes to Beth, what is the accumulator that gets passed? We defined our accumulator as the number of people we have seen thus far. When I reach Beth, I've already seen Anne. And so the accumulator that gets passed down should be the number of people I've seen thus far, which is Anne. Okay? And so staying consistent with that definition, well, whatever I pass to Bob has to be the total number of persons I have seen thus far. And that turns out to be whatever this.mom.countPersonHelp actually returned. Because when I'm calling this.mom.countPersonHelp, what it's returning me is when this tree ends, how many people have I seen thus far? And that is exactly where I would like the dad to start counting from. Okay? And so when we write down this, public int count person help int count so far. Okay. Now, this is a good example in that it kind of goes on the same lines as the list one. I just add 1 and pass the accumulator. But this is slightly more complicated because there are actually 2 things to call. And so the complicated one is when the time comes to call the second one, which in this case is the dad, what accumulator do I pass it? Okay? So you will notice with this that when we are done with this method, what the code we end up with, if that is the first thing you see, it's kind of hard to imagine how we came there. So that's why it's very important to kind of trace through your examples to make sure, break it down into steps. First, I'm going to send it to mom. Mom.countPersonHelp. And to mom, I'm going to send the accumulator I have gotten plus myself. So this thing is me. Okay? Now, whatever my mom's side returns to me, that will represent the number of persons I have seen thus far, including myself and everybody on my mom's side. And so that is the thing I end up passing. That is the thing I end up passing to my dad. Okay? So I told you when we write the code, reading it all at once seems confusing. But it helps to kind of construct it step by step. Number 1, I'm going to call my mom's side. It is going to return me the number of persons I have seen thus far, including myself and everybody on my mom's side. And so that is the number I would start my dad, would like my dad to start counting from. And that's why that is the accumulator that I give to my dad. And so this ends up being step 2. Okay? Questions? What is the takeaway from this example? There are 2 takeaways from this example. First, it is very important to be very clear about what your accumulator represents. You can't just cook up a value from somewhere, because if you define it clearly, then that definition is what will tell you how to update it. It should be very clear what the accumulator represents. It's not just a number. You have to pay attention to what it represents. Okay? And then the updation is simply, how do I stay true to that definition? If the accumulator represents the number of persons I've seen thus far, all right, so when I call my mom, what is that number that my mom should see? When I call my dad, what is that number that my dad should see? Okay? So step one is very important because it leads you to step two. Number two, you have to understand that although when you write this down, it all looks like one line of code, we are really breaking it down into steps. Do not try to directly come to this code. You have to break it down into steps. If possible, write it in front of you. Step one, step two, step three, step four. Then write the code step at a time. And as we just did, as we are writing the code, all of it happens to fall on one line. But do not try to go from, let me solve this problem, to here's the code I should end up with. That is too big a jump. Break it down into steps. Write down the code for every step, and then combine it. Okay? There are absolutely no points to be gained trying to come up with this directly. You're putting yourself through unnecessary torture and misery. Okay? All right. So the count ancestors, female ancestors over 50. I'm going to leave that to you because it is going to be similar to the count ancestors. You don't have to just count everybody. You have to make sure that the person you're including does fulfill the condition. Okay? That's all I will say. Try to tackle that method by yourself. The lecture notes do have a solution for it. I really recommend that you not look at it. Give it your best shot, and then use the lecture notes as kind of the solution key to see how close you are. All right? Okay, so well-formed. So well-formed, as I said, is going to use the years of birth. And IAT is well-formed if for every person, the person is born after both of their parents. And this is true for the entire tree. This is true for every person in the tree. Okay? If the person's parents are unknown, one or more, then we assume that from that side, the tree is trivially well-formed. So for example, if you just consider Caitlin, this tree. This Caitlin's both parents are unknown, and so that part of the tree is trivially well-formed. Okay? So we are essentially looking for conflicts. If there is no conflict because, well, the years of birth are consistent or because the years of birth are unknown, then we assume it's well-formed. All right? So let's try to see how to solve this problem. Let's begin with non-accumulator again. The tree starting here is well-formed if, finish that sentence for me. The tree starting here is well-formed if, the tree starting at an, let's say here means an right now. The tree starting at an is well-formed if, who can finish that sentence for me? Yes? If Anne is younger than Anne's dad, which is Bob, and Anne is younger than Anne's mom, which is Beth. That's it? And the mom's tree is well-formed, and the dad's tree is well-formed. Okay? So the tree starting here is well-formed if this person is younger than the person's mom, and this person is younger than the person's dad, and the mom's tree is well-formed, and the dad's tree is well-formed. Does everybody understand this? All right. If so, then the code follows itself. There really is no magic to this. It really does happen. The converse is probably also true. If you don't bother with trying to clearly explain what you want to do, you may still get the correct answer. You'll likely spend more time than you had to get there. Okay? So, Boolean, well formed. So this tree is well formed if this person is younger than the person's mom. How do we solve that? We know this person is younger than the person's mom if this person's year of birth happens to be after the mom's year of birth. But we run into the tiny problem that we don't know for a fact that the mom is a person. The mom may not have a year of birth for us to compare. All right? So we're going to write a method. We're going to wish for one that my template says what are the things I do have access to. I'm in the person class, so I do have access to this.yob. Okay? I have no idea about mom's YOB if my mom even has a year of birth. If it's unknown, then there is no such thing. And so I'm going to delegate to the mom saying, hey, mom, were you born before this year? Okay? So born, you could be born in or before. So I'll just make it before. Technically, it should be less than or equal to. All right? So this tree is well formed if the mom was born before this person and the dad was born before this person and the mom's tree is well formed and the dad's tree is well formed. If all of these are true, then return true. If even one of these is false, return false, which is why I've used and so all I need to do is simply return the result of this Boolean expression. The tree starting at this person is well formed if this person's mom was born before this person and this person's dad was born before this person and and the mom's tree is well formed and the dad's tree is well formed. All right? So these, of course, are wish lists. These are part of the wish lists. Okay? So let's finish them off. We write it in the interface, Boolean born before a given year of birth. Okay? Now, here we have Boolean born before. So I'm in the person class right now. So in the person class, my template says I have access to this.yob. And I'm past a year, and I'm supposed to tell you if this person is born before the year that was passed. Okay? So this person is born before the year that was passed to me if this.yob happens to be less than the year that was passed to me. Okay? So if this.yob is less than year, return true, otherwise return false. And I can write that simply like this. Okay? Now it's part of the interface, which means I have got to implement it for the unknown as well. So we've been kind of skipping things for the unknown. But this one, I'll attempt. Okay. Now, this one is kind of clunky to answer. Is this unknown born before the given year? What should we return? Is this unknown born before this year? True. Is this unknown born before this year? Technically, the correct answer would be, I don't know. Okay? And in the previous method, the younger method, is this person younger than the other? Or give me the person that is younger from unknown and some other person. And there the answer was cleaner, right? It can't be me because I'm unknown. So I'll say the other person is younger. This one is a slightly more difficult pill to swallow, because I'm directly asking, is this unknown person born before a given year? And technically the answer should be, I don't know. I can't answer that question, right? Because even if I say yes, well, why? I don't know the year of birth, so how can I definitively say yes? I say no, but why? I don't have a year, so I can't definitively say no either. Okay? So it's kind of clunky. Now, if we look at where it's called from, it's called right here. So let's kind of turn this on its head and say, well, if my mom was unknown, what would I like that method to return so that this method actually works correctly? If my mom was unknown, what would I like this method to return so that this method actually works correctly? So if born before returns me false, I'm done. This method is going to return false. And that would mean if this person has a mom that is unknown, this tree is not well formed, which is not what we want. We said from the outset that if one of both parents are unknown, then as far as that unknown side is concerned, the tree is well formed. So looking at it strictly from the point of view of this method exists just to help this method. So what should we make this method return so that this one works correctly? And the answer to that question is, well, if this.mom is unknown, born before should return true. Okay? And so to make this work correctly, my born before should return true here. Okay? I put a question mark there because we just argued that technically it should not be returning true, because if pieces of data are missing, I cannot definitively answer that question. Okay? So there's something shady about this design. We kind of forced it to return something that we know will make our original method work correctly. But it doesn't seem, what it's returning doesn't seem to gel perfectly with what we wrote as the purpose statement of that method. According to the purpose statement of the method, the answer here should be, I don't know. Not only do I not have a good way of saying I don't know, because this method returns a Boolean, but what this method returns is going to make this method work correctly or not. Okay, so we'll put a pin on that. Let me first see if everybody has understood this method before we come back to this problem. Are there any questions? With the caveat that that born before doesn't always seem to be doing what its purpose says it's doing. None? Okay. So that was problem number one. Problem number two with this, it's not so much of a problem as it's an oddity, right? When you go further beyond fundies 2, perhaps beyond OD, you will hear a term. It's an informal term. It's called a code smell. Anybody venture a guess as to what code smell could mean? What do you think the phrase code smell means? How many of you have had bad food in the refrigerator before? How do you know there's bad food? Well, your hope, like you'll see stuff growing on it. That clearly means it's bad. But sometimes you can't see things. So how do you know if something has gone bad? Smells bad. How do you know what you're smelling is a bad smell? How can you smell something and definitively tell me, yep, that's gone bad? That's not so clear cut because good smell and bad smell is kind of subjective, right? And so we can smell food and we can say, yeah, that's suspect. I cannot definitively say that that food is bad, but yeah, that smells weird, right? So code smell is kind of like that, but in code. A code smell is you look at the code and there are things about it that appear undesirable to you. In many cases, you can articulate exactly why it is undesirable. But in some cases, you know it's undesirable. You can't quite put your finger on why. Okay? So code smell is this overarching term that people refer to saying, okay, these are sort of red flags in the code. It might be as simple as the indentation is all over the place. Like, I can't read this. I almost don't care if it works correctly or not because I can't understand what it's doing. Okay? It might refer to design that is kind of hacky, shady, right? And so a big part of software maintenance is to basically remove code smells, to detect them and then to address them. Okay? So this is what I would call fishy, exactly, Lou. So this is what I would call a code smell. I got it to work correctly, like well-formed works. But when I look at the implementation in unknowns, something doesn't add up. I'm so used to writing a good purpose statement and then having the code exactly follow that purpose statement that here something is amiss. It's returning true, and that doesn't quite gel with the purpose statement. Okay? The second code smell kind of is over here. So first you are asking the mom. First you are asking the mom to do something. Check if you are born before this year of birth. Okay? And then 2 lines later, you're asking your mom to do something else. See, you are asking your mom to do 2 separate things. So it's as if you sat on the tree and you said, Mom, here's a question. And then mom answers. And then 2 steps later, you said, Mom, here's another question. It would be nice if I could, bundle all the questions all at once and call something on the mom side just once. So that's the other code smell. This is not so much bad. It just seems unnecessary that I have to break this down into 2 steps. So let's see if there is a better way to implement this method that combines both of them. Okay? So how might we combine both of them? Now imagine you call this one method on your mom's side that is supposed to do both. Check if the mom's side is well formed. So that part it can do, no problem. Okay? But in order to do that, imagine you're the mom. You need to find out the answer to that question. Am I born before? Before what? I need to know that. Okay? So from the mom's perspective, the parameter that is passed is actually the year of birth of the child. And so instead of sitting here and saying, I want to check if my mom is born before me, I'm flipping the question and instead saying, my mom asks, am I born after my child? Okay? If only the mom had access to the year of birth of the child. Does everybody get that? I'm trying to answer both of these questions, but from the mom's perspective. So the mom can tell if mom's tree is well formed. So that third line is okay. But the first line, flipping it from the perspective of the mom, it is, am I born before my child? And so I can answer that question with a method if that method takes the child's year of birth as a parameter. So I'm going to flip that around. Okay? And then I can combine both of them by writing a method like this. Boolean well-formed help. And it's going to take the year of birth of the child. Okay? So given, the purpose statement of this would be, given the year of birth of the child, of my child, am I a well-formed tree? Okay? How might that work for the person? So for the person, well-formed help. So first, I'm going to check if I am born before my child. So my template says this.yob is something I can access. I already know the child's YOB, so this becomes simple. It becomes this.yob happens to be less than what is passed to me. Okay? And now I want to check if my tree is well formed. My tree is well formed if my mom's tree is well formed. But in order for my mom to check that, she needs to know my year of birth. She needs to know my year of birth. And similarly, is my dad's tree well formed? But in order for my dad to know that, to determine that, my dad has to know my year of birth. And so I'm well formed if I am born before my child and my mom's tree is well formed and my dad's tree is well formed. And so the answer to this is simply if all of these happen to be true, then that's the case. All right? Don't you want to separate the responsibilities so that it's easy to debug? I think I'm reading this comment a few minutes later. You typed it. So, Liv, could you clarify in what context you meant that?
Hello? Can you hear me?
Yes.
So I was thinking that this.mom.born before and this.mom.wellformed, there are two different methods that do one thing very well. And I think in Fondy's one, we were taught that you're supposed to separate them instead of merge them together into a bigger method.
Correct. So I see your point. The advantage of designing it this way is that each one of them has a clear formed purpose and it is of one purpose. Okay. The bad thing was about that born before that seems to have a clear purpose, but then we have to implement it in a way that kind of doesn't stay true to its purpose. So your point is well taken. There does not, each one of these alternatives seem to have certain things about them that are not quite perfect. I'll give you that.
Thank you.
Okay. Other questions about this? So what are we really doing if you think about it? This thing right here is acting like an accumulator. Why? Because it is telling you something about something you have already seen. By the time I come here, the only way I could come here through the IAT is through my child. And so that child YOB is representing something that I have already seen, right? So it's not an accumulator in the sense we have seen before. It's not trying to gather or in some ways add up things that I have seen before. It is remembering exactly one thing from before. A simpler way of putting it is that accumulator is exactly one step behind me. If I'm here, then the accumulator represents the year of birth of my child. When I go one step down, the accumulator here represents the year of birth of my child. And the reason for that is because the well-formed nest requires some data from yourself and some data from one step behind you. And that's why you kind of go down the tree kind of in lockstep, where you hold on to something one step before you. But that's an accumulator. Remember I said the accumulator is either something that is what you're looking for, or in this case, it is something based on what you have already seen that is going to help you get what you want. Okay? So this is a slightly different flavor of an accumulator that we have. Let's complete this method here. Well-formed help. These should be public. Well-formed help. Int child YOB. Given that this is the year of birth of my child, am I well-formed? Well, I am unknown, so trivially, I am well-formed. Okay? This one better aligns with its purpose than the one before it, the born before. Okay? Now, if it is an accumulator, then what happens to this method right here? So instead of this, I can say I am well-formed. So the very first time for Anne, how do I know this tree is well-formed? Well, it's well-formed if my mom's tree is well-formed, given my year of birth, and my dad's tree is well-formed, given my year of birth. So remember, step 3 of the accumulator is when the whole thing starts, what is the initial value of the accumulator I pass? And so where does the whole thing start? It starts with Anne in our example tree. And so when it starts, this is again something slightly different than what we have seen. The original method is calling the helper on the mom and the dad, not itself. In all the previous cases, count was this dot count was calling this dot count help. Here, well-formed is calling mom's well-formed help and dad's well-formed help. Okay? You don't need to remember these little program, which function calls when. Always go back to the purpose. This tree is well-formed if my mom tree is well-formed, given my year of birth, and my dad's tree is well-formed, given my year of birth. Once you come to that conclusion, the code will follow. Okay? I have seen too many students kind of, when the problem needs to be solved, they go directly in thinking about, okay, this is the method I'm going to call. This is the method I'm going to call after that. I'm not saying that's a wrong approach. I just think you're more likely to get stuck in the weeds when you directly attempt to talk in Java, when you're trying to solve the problem. It's too big a leap. Okay? You'll get there. You'll get there. But only when you have enough, if you've had enough practice kind of thinking about the concept in terms of code. For most of us, it takes years to get that same level of comfort as we do with plain language. And so don't force it. Solving the problem and then implementing it in Java. These are two different things. Let them be two different things. Don't try to directly speak in Java or in terms of calling functions when you're trying to solve the problem in the first place. Okay? Not only is it easier breaking it down into steps like this, but you will gain the knack of how to solve a problem without being so dependent on Java syntax. Because solving the problem does not involve knowing Java at all. So stick with plain language and then convert it to code. Does that make sense? All right. So that was the well-formed. What I'm going to do is I'm going to come back to the first method that we tackled, this younger over here. I'm going to kind of have a couple of methods that are similar to this. So the first one I'm going to do is get the youngest parent. Okay? And so IAT, youngest parent. Okay? Given this IAT, I want to return the youngest parent of this IAT. So if I call it on AN, and these are the years of birth, then if I call this method on AN, I expect it to return that. Okay? So actually, I'm going to go ahead and give years of birth. For each one, for our example, for easy reference. Okay? So, what is the youngest parent of Candace? Youngest parent of Candace? Yeah, because we don't know the year of birth, so this one is the youngest parent. What is the youngest parent of Caitlin? Yes, the youngest parent of Caitlin is unknown. Why? Because both parents are unknown. Okay? What is the youngest parent of Candace's dad? Well, Candace's dad is unknown. And so we don't know anything about the parents. And so the youngest parent is unknown. Okay? So when we implement it here, public youngest of public IAT youngest parent. The answer is simple here. Is unknown. Okay? Of course, the more interesting case is when I'm asking this question of a person. So Anne, the youngest parent of Anne is Ben. The youngest parent of this person is, try to finish that sentence for me. The youngest parent of this person is somebody who is remote, somebody who's not Luke. Luke periodically asks questions and gives answers. So somebody else. People who are remote, you don't realize it, but all of us are staring at you right now, hoping that one of you gives us an answer. Finish that sentence for me. Raise your hand if you'd like to take a try. The youngest parent of this person is. "67 of you." I'm going to keep extending this awkward silence until one of you is goaded into. Kevin says, if this dot mon dot younger, this dot that. Caitlin says the parent with the greatest year of birth. Caitlin, you're correct, except that breaks down when I'm asking that question of Candace, because one of her parents' year of birth, I do not know. Okay? So putting it simply, the youngest parent of this person is the younger of this person's mom and this person's dad. Right? You take this person's mom, you take this person's dad, and you find out, hey, out of these two, who's the younger one? Okay? Now let's look at the template for the person. We have this dot yob, we have this dot mom, and we have this dot dad. And then what are the methods we can call on mom and dad? Here are all the methods we can call on mom and dad. And the first method is, given this other IIT, return me the one that's younger between you and this other IIT. So we can use that. That's part of our template. And so here we can use it to implement this method. Youngest parent. I wish to return the younger between this dot mom and this dot dad. Okay? And simply return that. The youngest parent is the younger between mom and dad. Right? With me so far? All right. I'm going to keep asking these questions until I get a robust response. I seem to have scrolled too much. There we go. So now I would like you to tackle get the youngest grandparent. Okay? Now, again, For those of you who are remote, please raise your hand instead of directly typing in the answer to give benefit to other people who are trying to work through it as you think you already have an answer. But once again, I would like you to tackle this for the person. The youngest grandparent of this person is. Try to finish that sentence. For those of you who are remote, again, if you think you have it, just raise your hand. Do not type it in the chat. All right, let's see. Ivan.
This dot mom dot youngest parent.
English.
Call that.
Plain language, please, not Java.
Oh, okay. The younger of the youngest parent of the mom versus the dad.
Versus the youngest parent of the dad.
Yes.
Okay, good. The youngest grandparent of this person is the younger of the youngest parent of the mom and the youngest parent of the dad. Okay? Does everybody understand? So, time to convert it to code. It is going to be the younger of my mom's youngest parent and my dad's youngest parent. Okay? So, the youngest grandparent is the younger of mom's youngest parent, which is this right here, and dad's youngest parent, which is this right here. All right? Everybody with me? Any questions? All right, good. If you have understood this, then how about this one? Get the youngest person from oh, crashed. Let's see. Please don't make me write one note. Oh, it does understand my handwriting. Let's see how much of that survived. Ah, it did. Okay. Get the youngest person from the xth generation. So IAT from the, I should say, from the given from X generation. And let me articulate that better. From X generations away. So IAT, youngest from Gen. Am I not sharing? Thank you. Okay, so youngest from generation, int Gen. All right, tackle that for me. I would like to get the youngest IAT from X generations away. So that's X, the int Gen. So if Gen is 1, it means get the youngest from 1 generation away, which is the same thing as get me the youngest pair. If X is 2, if Gen is 2, it means get me the youngest from 2 generations away, which means get me the youngest grandparent. If it's 3, then it's youngest great grandparent. Okay? So once again, if it has worked well for you thus far, the youngest, I shouldn't say person, IAT. The youngest IAT from X generations away is, try to finish that sentence. So again, if you're remote and you think you have it, raise your hand, don't type it out. The youngest IAT from X generations away is, anybody take a stab at it? Yes.
All right, so I was thinking we need like an if statement to check generation 0.
Okay.
And if it is, then we would just return this.
Okay.
And then if generation is not 0, so else we need the, I guess we're supposed to we need the youngest from, like, we could like change the generation by 1. By, it's hard to explain in English, but like, we gotta subtract, do like the next youngest from Gen for the mom and the dad, and then do the dot younger of both.
Okay. There is a way to say that in English that, I mean, arguably, at least to my ears, is clearer. You're on the right track. You're not wrong. Somebody else wants to kind of articulate more clearly how to tackle this? Let's see. Luke, go ahead.
Get the youngest IAT from X generation away as long as in Gen is not 0.
Okay, let's tackle that one. So if it is not 0, then what?
You keep looking for the generation. If it's 0, you return that generation. You basically use it in generation as a countdown.
Okay, so if it is not 0, then what do I do?
You would recur again.
How exactly? That's the part I'm after. The youngest IAT from X generations away is, finish that sentence for me. Yes.
It's the younger
for the parents. So the youngest IAT from X generations away is the younger of the youngest IAT X minus 1 generations away from my mom and the youngest IAT X minus 1 generations away from my dad. Okay? The way if you could not articulate it, try to relate this to parents and grandparents. I express the greatest grandparent 2 generations away in terms of youngest parents 1 generation away. Okay? And so, in other words, my youngest grandparent can be chosen from my mom's parents and my dad's parents. So 1 generation less. The problem is I may have a generation that will stop halfway through. So I need a case that what if the generation is 0? Okay? So what does it mean when I say get me the youngest IIT from generation 0? Who is generation 0? Well, I am. In my tree, in a tree that starts with me, I am generation 0. In fact, I'm the only one from generation 0 in my tree. Because remember, the tree doesn't store my siblings. Okay? So therefore, in this entire tree, who is the youngest IAT of generation 0? That would be me. Right? Because I'm the only one of generation 0 in this entire tree. And so, we'll write this and then we'll end class. Public IAT youngest in this. If it is generation 0, then I'm it. Otherwise, it is going to be the youngest of generation X minus gen minus 1 and the youngest from gen minus 1 on my dad's side. And those two are going to duke it out. So whoever is the younger of the two. And that's the one I return. Okay? So we are out of time. Let's stop here. But go over this, and then lecture 8 gives you 3 or 4 problems to tackle. The way I want to tackle that in class is that I won't spend an entire lecture talking about them. What I would like you to do is try to tackle each one of them. And then in the next 3 or 4 lectures, we will begin class by talking for the 5 minutes about one of those problems. Okay? But today's Thursday, so you have the weekend to kind of try to take your best shot at those problems. Thank you. Stop recording.